Today's topic is going to be least common multiple of algebraic expressions. We have seen least common multiple for terms or numbers, so we will review a little bit of that and then we will use it in algebraic expression. Remember, the least common multiple is the smallest number or term that can be divided by every number term in the group of terms we have. Do not get confused between less common multiple, that it's the one we are talking about today, and the maximum common divisor. Remember, the maximum common divisor is the number or the highest number that can divide a group of terms. The least common multiple is the smallest number that can be divided by every number or term in the group of terms we have. In this case of exercises, remember we use a process that it's called prime decomposition in order to know the least common multiple. So let's see how to obtain the least common multiple of monomials first, and then we will see how to obtain the least common multiple of polynomials. So in the case of monomials, we will use the prime decomposition of the numbers, and then we will select the highest power of every variable, that means every letter we have. So let's see. First, I will do an exercise with only numbers to remember how to do it, and then we will put also letters. So imagine, first example, is going to be obtaining the least common multiple between 180, 90, and 375. Remember, we need to use prime decomposition. So in this case, we will start doing it. So we will start with number 2, and it's going to be 90 and 45. Then we can continue with number 2, and it's going to be 45, 45, and 375. Then we will continue with number 3, and it's going to be 15, 15, and 125. Then we can continue doing it by number 3, and it's going to be 5, 5, and 125. Then it's going to be by 5, and it's going to be 1, 1, and so it's going to be 25. So it's going to be 5, it's going to be 1, I'm sorry, 5. I don't know what I'm doing here. It's going to be 5, 5, and 1. So now we need to multiply every number. So it's going to be 2 times 2, 3 times 3, 5 times 5. So it's going to be 4 times 9 times 25 times 5. So it's going to be 36. That multiplies 125. So if I multiply 125 times 36, it's going to be 4,500. So the least common multiple between those three numbers is 4,500. So it's only using the prime decomposition in order to know the least common multiple of numbers. Let's see how to do it when we have numbers and letters. So in this case, we have two different terms, 120a cubed b squared c to the 7 and 90a squared b to the 5x. So remember, we need to do the prime decomposition of the numbers, that it's going to be 120 and 90. So it's going to be, if I divide it by 2, it's going to be 60 and 45. If I divide it by 2, it's going to be 30 and 45. If I divide it by 2, it's going to be 50 and 45. Then I can divide by 3, and it's going to be 5. And it's going to be 15. then it's going to be divided by 3, it's going to be 5 and 5, then finally 5, and it's going to be 1 and 1. So it's going to be our least common multiple, it's going to be 8 that multiplies 9 that multiplies 5, so it's going to be 9 times 5, it's 45, times 8, it's going to be 360, so it's going to be 360. What about the letters? It says select the highest power of every variable we have. So first we have A, B, C, and X, and we need to select the biggest one. So in the case of A, it's going to be to the third power. In the case of B, it's going to be to the 5. In the case of C, it's going to be to the 7. And in the case of X, it's going to be to the 1. And this term will be the least common multiple of those two monomials. So it's very easy. It's only using the prime decomposition of the numbers and then select the highest power of every variable or letter we have. So it's very easy. I think it will be only one last exercise of how to obtain the least common multiple between monomials. So in this case, it's the same. We need to do the prime decomposition of the numbers. So we got 25, we got 75, and we got 125. So in this case, we can do the prime decomposition of the numbers. So it's going to be first divided by 3. It's going to be 25. It's going to be 25. And it's going to be 125. Then we can use division by 5, and it's going to be 5, 5, and 25. Then we can continue dividing by 5. Finally, by 5, it's going to be 1. So if we got that one, it's going to be 125 multiplied by 3. So if I multiply 125 multiplied by 3, it's going to be 375. Then with the letters, remember we need to write every letter we have in alphabetical order. It's going to be A, B, C, and M. And we need to select the highest power. So in the case of A, it's cubed. In the case of B, is squared. In the case of C, it's to the 7. And in the case of M, it's squared. And that will be the least common multiple between those three monomials. So let's check out now how to do the least common multiple of polynomials. In the case of polynomials, it says on the steps, we will use any type of factoring to decompose the polynomials, and then we will select the highest exponent of every factor. Remember, a factor is something between parentheses. So we will select the highest exponent of every factor we got after factoring. So let's see some examples. So of course, in this type of exercise, we'll need to review the types of factoring cases. We need to check out and remember what we have seen on last videos and last semester. This polynomial is a difference of squares. This one is a difference of squares. So we can factorize it as the product of the sum and difference of a binomial. So it's going to be the one that it's positive, it will be positive on both, and the square root of the other one will be positive in one parenthesis and negative in the other. This one, it's an x squared plus bx plus c trinomial, or we can check out also if it's not a perfect square trinomial. So let's check out. In this case, if we check out the square root of this one, it's x. The square root of this one, it's 3. If I multiply those times 2, I will get the 6. So yes, it's a perfect square trinomial. So it's going to be x minus 3, all of it squared. So we have factorized every polynomial we have. It says select the highest exponent of every factor we got after factoring. So we have two different factors, x plus 3 and x minus 3. And we need to select the highest power of them. The case of x plus 3, we only have it on the first one and to the 1. So it's like this. In the case of x minus 3, we have it to the 1 here, but we have it to the second power here. So we need to put here to the second power since we need to select the highest exponent of every factor we have, and this is going to be our least common multiple. So it's very easy. We only need to factorize the polynomials, and after that we will select the highest exponent of every factor we have after doing the factoring. So it's very easy. Let's see another example. So in the second exercise, we have something like this. We have two different polynomials. We need to factorize them in order to know what kind of least common multiple we have. This one that we have here, it's a little bit difficult to know sometimes, but if we check out, this one has a specific cubic root that it's 2x. This one has a specific cubic root that it's 1. This one is going to be 3 times the first one squared multiplied by the second one. And this one is going to be 3 times the first one multiplied by the second one squared. And the signs are positive, negative, positive, negative. They are alternated. So this one, it's a perfect cube polynomial. So we can factorize this one as 2x minus 1, all of it cubed. This one, it's a difference of cubes. So if we remember how to factorize a difference of cubes, then it's going to be the square root of the first one, that is going to be 2x, the cubic root of the first one, the cubic root of the second one, and in the other parenthesis is the first one squared plus the multiplication of both of them plus the second one squared. So we have factorized every expression we have. So the next thing is select the highest exponent of every factor we have. We have two factors. We have the 2x minus 1 and we have the 4x squared plus 2x plus 1. So in this case, 2x minus 1, we have it here to the third power and here to the 1. We need to select the biggest one, so it's going to be to the third power. And the other one, we have it only to the 1, so this one is going to be our least common multiple. So remember, this kind of exercise, it's not difficult if we remember factoring, but if not, it's a good time to review factoring again. So let's see another example. So in this case, we have three different polynomials, but the process is the same. We need to factorize every polynomial, and then we will select the highest exponent of every factor we have after factoring. So this one is going to be a difference of squares. So how to factorize a difference of squares? It's going to be 2x plus 5 that multiplies 2x minus 5. That is the square root of the one that it's positive, positive on both parentheses, the square root of the negative, positive on the first one, negative on the second one. This one, it's a perfect square trinomial. Why? Because this one, it's x. The square root of this one is 1. If we multiply them by 2, it's the middle one. So this one is going to be x plus 1, all of it squared. This one, we need to check out this one. It's going to be 2x. This one, it's going to be 5. If we multiply those times 2, 5 times 2, it's 10 times 2, it's 20. So it's also a perfect square trinomial. If I factorize this one, it's going to be 2x minus 5, all of it squared. And then remember, to know the answer, we need to write every term we have, or every factor, every factor we have. So in this case, we have the factors 2x plus 5, 2x minus 5, and we have also the x plus 1. And then we need to select the highest exponent of every factor. The 2x plus 5 only appears here, so it stays the same. But the 2x minus 5, we have it to the 1 here, to the second power here. So it's going to be to the second power here. And the x plus 1, something similar, we have it to the second power. And this is going to be our actual answer for the least common multiple of those three polynomials. So it's kind of easy. It's only remember factoring cases. So we factorize every polynomial and then we write every factor we have and select the highest exponent of every factor. So that will be it for least common multiple of algebraic expression of both monomials and polynomials. Thank you for listening. We'll see each other on the next video.